Okay, all right, so now we are on the mean value theorem. Show that the function satisfies the hypothesis of the mean value theorem in the given interval AB. So here's my interval. Find the value of C in AB that satisfies the equation. Okay, so first thing you want to make sure that it satisfies is that in almost all of the theorems in calculus is that you have to have the function being differentiable and continuous. Right? If you scroll all the way up to where mean value theorem says, it says the function f of x is continuous and differentiable, meaning it has a derivative, it has a slope on every single point. Okay, so what do I know about this function? F of x is equal to x squared plus 2x minus 1. This is a parabola. Even if it's not a parabola, this is a polynomial function. I have no fraction, so there's no vertical asymptote. I have no even roots, so there is no problem of a vertical tangent. And I don't have logs, so I don't have any issues with negative numbers. And I don't have absolute values where there's going to be a possibility of corners. So polynomial functions are the best functions to work with because they're always differentiable and they're always continuous no matter what interval you choose. So first thing you want to say is part A is that f of x is continuous and differentiable on the interval 0 to 1, right? It is well, let's close the interval. Close interval 0 to 1. I apologize, this must be a closed interval too. Right, so therefore it satisfies the hypothesis of mean value theorem, MVT. All right, the hypothesis in this case is used to describe the conditions for you to be able to use the mean value theorem. So it satisfies the condition, therefore we can use it. Okay, all right. So this is, remember, this is where we talk about where the instantaneous velocity is equal to the average velocity. So it's where your f prime equals your slope. Slope is y2 minus y1 over x2 minus x1. So figure out what you want to do first. For me, I probably will do the slope first. All right, so because I'm a little bit more comfortable with that. So I'm going to say, all right, slope. This is my x1, this is my x2, not x1, y1. Those are your x's. You need to plug them in to figure out your y1 and y2. That's your f of b and f of a. So plug 1 into your function, original function. That's 1 squared plus 2 times 1 minus 1. So it's 1 plus 3 minus 1 giving me 2. And the f of 0, that's my second y value. You plug in 0, you get 0 squared plus 2 times 0 minus 1, negative 1. So your slope, your average is going to be y2 minus y1 over x2 minus x1, right? Your x2 and x1 are 1 and 0. That gives me 3 over 1, which is 3. Okay? All right. Isn't f of 1, 1? F of 1, 1. 3. 3 minus 1. Okay. All right. Good. We got that cleared up. All right, so you got your average, you got your slope to be 3. Now, your next part is to find your derivative. So take your function, so f prime of x equals 2x plus 2. That's your f prime. So now you got to set the two of them equal to each other. You got to take your f prime and set it equal to the slope you just got. So slope is 3. And you're solving for the x value that it is happening at. All right, so you're solving for the x value. I know your problem says c. It's just x. It's the same thing. I think it's easier if we address it as x, right? So go ahead and solve for this. You get, okay, so I subtract 2. So I get 2x equals 1, x equals 1/2. So that c value, the x value that you want, is when x equals 1/2, right? So you can just say c equals 1/2. So again, what does this mean? It means that if I were to take a road trip, right? So between 0 to 1, so between 0 to 1 hour, when is my average speed going to equal to the instantaneous speed? Well, in this case, if I'm following this function, then at half an hour, that's when my instantaneous is going to be equal to my average. All right, so that's what MVT is really asking us. Okay. All right, so now let's kind of look at backtrack a little bit. This is a separate idea of what we're doing. So, okay, set mean value theorem aside. It's going to come back in. Please make sure you are comfortable in taking the derivative and taking the slope and setting them equal to each other. This is a very common topic on the AP test, so make sure you're comfortable with this idea. All right. Okay, so set that aside. Let's move on to 5 and 6. It says find all possible functions f with a given derivative. So this is where we're going backwards. What function gave me the derivative of sine x? Well, if I think whose derivative is sine, I know the derivative of cosine is negative sine. So in order for it to be a positive sign, then maybe my original function needs to be negative so that I get negative, right? So that means my original function must be a negative cosine x, because then if I take the derivative of negative cosine x, I have negative, and the cosine x gives me a negative sign, so negative sign makes a positive sign. Okay, I got my derivative. But keep in mind, I can always add a constant to this, because any constant I add to it, the derivative is 0. It's gone. So again, use your finger literally to cover up the sine x and look at just this function here and say, hey, let's take the derivative of that. The derivative of that is negative times negative sine x, which is positive sine x, and the constant is 0, so I get sine x. So this is, it covers all the possible functions that can have the derivative of sine x. I can put in any constant in that C. It can be a -2, it can be a plus pi, it could be plus 3,428, right? It doesn't matter because it's a constant. When we take the derivative, it's gone, okay? All right, next one's a little bit trickier. You have the derivative of 1 over x minus 1, right? So whose derivative is 1 over x minus 1? I can't really think of one, but if I were to cover this up and say, what about 1 over x? Somebody's derivative is 1 over x. And it's Miss Chu's favorite. It is natural log. So natural log, well, what if it's natural log of x minus 1, right? Does that give me what I want here? So let's see. If I were to take the derivative of this, and Miss Chu, why is it absolute value? Because you want natural log to be taken, you want the argument in the natural log to be a positive value, because natural log can't take anything less than 0. So you have to make sure that everything inside is positive. So usually natural log, we put an absolute value around it. It doesn't affect our derivative. So if I were to take the derivative, I would look at this and say, okay, well, the derivative of that function is 1 over x minus 1. And then don't forget chain rule, x minus 1 has a derivative of 1. So, okay, I do have 1 over x minus 1. This is my derivative. So this is truly my original function. But don't forget, same pattern as before. You can always tap on a constant, because that will not affect your function at all. It will make it so that your derivative is not affected by the constant. But the original function having the constant could be very, very different. All right. So again, don't forget to just write yourself a note. C is any constant, any number, right? It could even be E. E is a number. E to the x is not a number, but E to the 1 is a number. Okay. All right, so we're going to use that same idea to kind of help us with the next problem. We're now connecting back again with physics. And again, I just want to reassure you, if you're not comfortable with physics, this is as hard as it gets, and if you just follow the formula, you will be able to see a lot of the relationships. All right. So it says on the moon, okay, so it's not on Earth now, the acceleration due to gravity is 1.6 meters per second squared. So I do want us to kind of separate our problems here and kind of remind ourselves of what we do know based on the information given. So first of all, before I even tackle the problem, I know that acceleration is 1.6 meters per second squared. So A is 1.6, right? Actually, but it's gravity, so it's coming down. There's a direction, it's pulling it down. So negative 1.6 meters per second squared. So this is given, right? All right, so now it says if a rock is dropped into a crevice, I don't even know if I spelled it right, but oh well. How fast will it be going just before it hits bottom 30 seconds later? Oh, so there's a lot of information given here. So first thing it tells me, it is dropped. So when it's dropped, that means your initial velocity is 0 because you didn't throw it, you just kind of let it go, right? So V of 0 is 0. So that's the next hint it gave me, that the dropped, meaning V of 0 equals 0. So initial velocity is 0. All right. So now I can use these two information to help me figure out. So if I were to go acceleration, remember the order is position, velocity, acceleration. So original, then derivative, right? So now I have this acceleration down here. I want to go backwards and go, okay, I want go back 1 to get velocity, and I go back 1 more to get the original position. So if I go back 1, who gave me the derivative of negative 1.6? So who gave me that? So what does v of t look like? Well, v of t looks like that, negative 1.6 with a variable, right? Remember, if your original function is a linear function, then the derivative of it is just the slope, just the number right in front of the x. So same idea, if we were to go backwards and look at this and say, I have the derivative already as a negative 1.6 is a number, go backwards, then I just need to tap on a variable so that when I take the derivative, the variable is gone. Don't forget, you also have a constant, right? Just like what we did in numbers 5 and 6, anytime we go backwards, there's always that possibility of constant. But we do know what the constant is because we know that initially right here, v of 0 equals 0. So let's plug in that initial condition. So v of 0 equals negative 1.6 times 0. Well, v of 0 is 0. So 0 equals 0 plus c. C is 0. So sometimes the constant turns out to be 0, which is fine. Because then that tells me officially my v of t is negative 1.6 t meters per second. Okay? So that's really good. Now, continuing, you're dropped into a crevice, meaning that you're dropped here and you're dropping it into something that's going below the level you are at, which then means that initially where are you starting for your position? Your initial position is also 0, right? So your initial position, again, this key word here, dropped into a crevice here, right, tells me that the initial position, so initial position is 0, Z-E-R-O, right? So S of 0 equals 0. So again, how is that helpful? I can now take the velocity and go back one more derivative. So I got to go back one more layer. So take the, what function would have given me this negative 1.6t? So think about it, when you have a t, that means you had a t squared before, right? If you had t squared before, then your derivative is 2t. So you need that 2 in the front, but I have a negative 1.6. So if I divide the negative 1.6 by 2, then that should take care of the 2. So wow, Ms. Xu just said a bunch of things. So let's see, this is trial and error. What if S of t was negative 0.8t squared? Look at this number. If you take the derivative, you drop down the 2, multiply by negative 0.8 to get negative 1.6, and then the derivative is negative 1.6t. That's how I got the velocity. Don't forget there's a c there, again a constant, right? Anytime you're able to do that, anytime you're able to go backwards, you have a constant. So now I got to plug in my initial condition here and say, all right, S of 0 is negative 0.8 times 0 squared plus c. So 0 equals 0 plus c. C equals 0 again. So now this is the most important thing. S of t equals negative 0.8 t squared. Okay, so wow, with just the fact that our acceleration is 1.6 and we dropped into a crevice, I'm able to get the acceleration function, the velocity function, and the position function. I didn't even start doing the problems yet, but these three are going to help me answer the question. All right, so again, make sure you look through this and figure out how I got the A, the V, and the S. Okay, so now let's answer the question. This is now asking the question. How fast will it be going just before it hit the bottom 30 seconds later? So how fast, meaning what's the velocity, 30 seconds later? Okay, so that means then I can look at my function here and go, I'm looking really for V of 30. I'm plugging in 30 into my function because it's the speed of it. All right, so V of 30 is negative 1.6 times 30. That gives me negative 48 meters per second. All right, so again, Ms. Xu, why is it negative? Because it's going down. And does that make sense? Because you drop the rock, it's going downwards, so the speed is negative, so it's going down. The negative just means direction. It doesn't mean it's a negative speed. It means that it's going down instead of going up. And that's it. That's it. But again, if we didn't do all that prep work in the beginning, it is going to be very hard for you to answer this question because then you're going to have to go through all that stuff, all that information again, right? Okay, so part B, how far below the point of release is the bottom of the crevice? So how deep is this crevice, right? So what is it asking for? It is asking you when, right? It says when it hits the bottom. So it hit the bottom 30 seconds later. It tells you that it's going to hit bottom. So it's going to hit the lowest point possible 30 seconds later. So basically what I'm asking you is what is the position of it 30 seconds later? So then you go, all right, S of 30, right? Negative 0.8 times 30 squared. So negative 0.8 times 900. So how low is this? Negative 720 meters, right? So again, distance cannot be negative. Why does this say negative? Oh, I'm sorry, it's not showing up. Give me a second here. Sometimes it doesn't want to share, so give me a minute. It just decided to quit on me. All right, let's see. Hopefully we got it back. There you go. So the next part B, we're really looking for S of 30. It's the position at which, when is it hit the bottom, or it hit bottom 30 seconds later. So the position at 30 seconds is going to be negative 720 meters. Now, because you're asking for distance, it is better to answer your question as 720 meters. But again, don't forget, the only reason why it's negative is just direction. Instead of 700 meters up, this is 700 meters down. And again, it makes sense because it's dropping into a crevice, so it's going into below the floor, right? All right, last one. Instead of being released from rest, so this is going to change something. The rock is thrown into a crevice from the same point with a downward velocity of 4 meters per second. Okay, so now this is going to change things. So this is saying initially V of 0 is now negative because it's a downward velocity. Negative 4 meters per second. Okay, when will it hit the bottom and how fast will it be going when it goes? Okay, so now we got to change my equation. I still started with A equals negative 1.6 meters per second squared because gravity is not going to change. I'm still on the moon, but the initial condition changed. So then what does that do to me? It will change this equation right there. So it will say V of 0 is equal to negative 4. So you have negative 4 equals negative 1.6 times 0 plus C. Your constant is going to change. So your constant is actually negative 4. Your V of t is now negative 1.6 t minus 4. That's your velocity function. Okay? Then what's going to happen? It's still being dropped, right? So your S of 0 is still, your initial position is still 0. So that part isn't changing. But because your velocity changed, your initial function is going to change. So your initial position is still 0. So S of 0 is still 0 because you're still dropping this from that crevice. You're not going further in and you're not raising this up. So you're still dropping it from the initial point. So now your function is going to be S of t equals negative 0.8t because that, 0.8t squared, that came from the negative 1.6t. What about negative 4? It will give you negative 4t because remember, anytime you have a constant, you must have had a variable with it to have that constant number taken out as a derivative. And then don't forget your c. So I'm plugging the S of 0, so I get 0 equals negative 0.8 times 0 squared minus 4 times 0 plus c. So c equals 0, which is great. But then in this case, S of t now changed to negative 0.8 t squared minus 4t to be my function. Okay. All right. So now let's see what it says. So when will it hit the bottom? So we know, so this is kind of going backwards. We know how far the bottom is. We know that the bottom is 720 meters. So when will it hit the bottom? You need to put 720 meters equal to your position because that will give you the time, the t when this happens, right? So I get 720 equals negative 0.8 t squared minus 4t. All right, this is quadratic, so I'm going to add everything over. So 0.8 t squared plus 4t minus plus 720 equals 0. Okay. In the interest of time, I will tell you that this is not factorable, so I use quadratic formula, and I got t is about 27.604 seconds. Okay, so you will get two answers, right? Because this is quadratic formula, and this is where the negative answer doesn't work at all. So there is no negative time. So you can have negative distance, you can have negative velocity, but not negative time. So this is when this will happen, right? So when will it hit the bottom? It hit the bottom at 27 seconds, but that's not what I'm asking only. I'm asking for more. So here's one answer. It's going to hit bottom. I should not circle that. I apologize for that. Okay. It's going to hit the bottom at 27.604 seconds. Then ask how fast will it be going when it does hit the bottom. So you want velocity again. So how fast will it be going? So you take your 27 seconds and plug it into your velocity. So the velocity v of 27.604 seconds is equal to, I'm running out of space, negative 1.6 times 27.604 minus 4. All right. No, I don't expect you to do this part by hand, so of course use your calculator to help you. So you get negative 48.166 meters per second. All right. So if you want to really answer this question completely, you will say that the rock hits the bottom at 27.604 seconds, going negative 48.166 meters per second, right? Because that's the speed at which it is going. This is your velocity, okay?